Welcome to the Earth Science Education Channel, making sense of the world, one mystery at a time.
Hi, welcome to my YouTube channel. I'm Dr. K, a geologist with Metropolitan State University of Denver, and we want to investigate today a little bit about geology, why take an introductory geology course, and what is so special about geology. Now, when we think about geology, we think about all kinds of things like earthquakes, minerals, volcanoes, dinosaurs. Geology is actually a pretty broad subject. It comes in various flavors, like beautiful minerals, yes. We have fascinating fossils. Some of the most insane fossil finds have come up lately. We have insane landscapes that we can visit and try to understand and actually enjoy the beauty of the earth. And there's so much more to consider. Hot springs, groundwater. So let's take a little tour of why someone should actually take an introductory geology course and what is so special about geology as a science. So, an overview. What is geology? Well, when we talk about geology, or you say geologist, one of the first things that come to mind, probably with most of you, is oil and gas. Yeah, geologists looking for oil and gas, and some of us have a little bit controversial look at that thing. Yeah, do we need it? And all the environmental challenges that come with it. Oh, we think about mining, gold mining or extracting coal and other resources out of the ground. And this is the first two things that pop into our head. But it might surprise you. Geology is so much more. It's actually a very, very broad discipline. It includes things like, never would have guessed, forensic science and criminal investigations. Yes, geologists work in forensic labs because they are qualified because of their skills to, catch the bad guys by using some identification tools. We do alpine engineering, building superstructures in, around, and through mountains. One of the most insane projects, like tunneling underneath the Alps and other things. Great dams have come from geologic engineering. Space science, planetary geology, extraterrestrial mining is saying, are we nuts? Well, we're going back to the moon. And believe it or not, some of our universities here in Colorado offer now degrees in space mining. Wow, it's not too long before this becomes a reality. So geologists have their eyes on space as well. Environmental science and environmental engineering. That might be surprising to some. Yes, geologists are uniquely qualified to work in the environmental sciences. In fact, 40% of all geology graduates end up somewhere in the environmental industry. And they're often preferred hires over environmental scientists. It has some reasons. One of them that because geologists can be certified, like engineers, have a little state board exam and an emblem of approval. Geologists can have the designation of a certified professional geologist, a CPG. The environmental majors, not quite there yet, unless you go into environmental engineering. It might surprise you that geologists work actually in the environmental field. We do natural hazards and disaster mitigation, helps save lives and structures and buildings. Volcanoes and applied volcanology. I'm teaching volcanology. This is one of my passions, and I've taken students to Italy. We climbed Mount Stromboli's. We stood on top of Mount Etna, Mount Vesuvius, finding all these beautiful things, but also learning a lot about the Earth's interior doing so. Oceans and oceanography. Yes, we are tied to the oceans. The ocean floors are still a big mystery, and we are finding more and more things that are interesting due to geology. And for the more simple things, some you might expect, gemstones, gemology, jewelry, are all tied to geology. And of course, dinosaurs and museum science. Yes, geologists are also tied to museum science. It's just a small sampling of all the things that geology is, and there's so much more. I mean, you can add water, groundwater, big, huge deal in the geology industry. Now, having all of this and understanding it, then why should you take a geology class? Or why does geology matter? Or do we even care about it? Well, geology is a little bit of a stepchild in the science world. So why care about geology? Now, let's ask a simple question. Where does all this stuff come from you use on a daily basis? Well, of course, you go to the supermarket and pick it up, but how did it get to the supermarket? Well, it was made in a factory. How did the factory make it? Well, they need to have somewhere some resources, some suppliers to assemble whatever a factory does, and then how were these resources made? So sometime, somehow, down the line, we should come up with the starting point of it all. And interestingly enough, there is a saying that is absolutely true. If it didn't grow, it was mined. So whatever you do, you are tied intimately to the world of geology. If you like it or not, many products, majority of products you use around the house are actually start in the ground somewhere. I'll give you a simple example. Does anybody know where plastic comes from? How is plastic made? We're using a lot of plastic products. Oh my goodness. A never-ending story about plastics. But there was a survey made not too long ago that found out that 72% of Americans do not know that plastic is actually made from petroleum products, primarily oil. Oh yeah, the stuff we're drilling for, and we always say we should reduce, fossil fuels. Whoa. A percentage of that oil actually supplies our plastics that we use on a daily basis. So something that may be surprising to some of you. But here's your connection of plastics to geology. So, made from oil, coming somewhere from the subsurface, from the ground. Now that creates a dilemma. We want our lifestyle, but we need resources to live it. And that is sort of right now the tipping point between our desire for resources and our desire to protect the environment. Let's use something that you all have. I hardly know a person right now that does not own a smartphone. We all do. My goodness, we have become dependent on these things. And let me use a smartphone as an example, one that we all have, to illustrate a point of how geology impacts us all. So what about a smartphone? So let's first some statistical facts. Most of our cell phones are less than 2 years old. We always want the newest, the best, the most upgraded product. And they're coming out with cool new gadgets every year. And sometimes we can't wait. Oh man, when this new phone comes out, and I wish I could afford it. So, and we all, when we sign up for a new plan, and the cell phone carriers kind of battling it out, they often throw in the most new and exciting phone for us. So most of our cell phones are fairly young. The average weight of a cell phone with battery is about 150 grams. I weighed mine, so figure it out. About 5.3 ounces. Doesn't seem much, but this is sort of the weight of your cell phone. Now comes the question. Where do the cell phone materials come from? I mean, if you say, I have a Samsung phone, I have an Apple phone, probably somewhere made in a factory in China. Yeah, but this factory needs raw materials. They need transistors, they need circuit boards, they need wires, they need, casings. And then where do these casings come from? Well, there are suppliers that make those. Yeah, but how do they make them? What are the products? And this is where it gets interesting, because somewhere, as I illustrated before, somewhere along the line, we are starting with the Earth's material, we're needing to dig things up. So here we go. Everything in your phone is actually mined. There might be hardly anything that is not, but your phone is basically a product of mining. Let's take a look at some things, right? What about the plastics around it? We already pointed out to this one. The plastics around the casing around your phone, that's oil and gas. It's definitely geology. Coming out of the ground, we're drilling for oil and gas somewhere. What about the screen? Well, it's made out of glass. Where does glass come from? What are the raw materials for glass? Well, here we go. Glass is usually a molten combination of feldspar, quartz, calcite, mica, gypsum, all minerals. They're industrial minerals that are mined. So, yeah, the glass casing or the screen is also a product of geology. Of course, a battery. Everybody talks about the battery. So what do we need? I actually listed some minerals. They may not tell you anything right now, but there's a mineral called spodumene. That's one of the largest lithium sources in the mining operation. And of course, we can say, lithium we can make differently. We can extract it from salt brines and salt water. This is true, but still, spodumene mining supplies quite a bit. We have manganite. It's a source of manganese, nickeline, one of the most famous nickel ores. We have spinel, a certain type of spinel, a cobalt-bearing spinel that gets us the cobalt. And there's, of course, more that goes into the battery that makes our system powered up. And I haven't even touched the electronics inside yet, the circuit boards, the resistors, the wiring, there's different wires, silver, gold, copper wiring, all kinds of things that goes into making a cell phone. So it's just a small sampling that is actually mined. Now, what we need to keep in mind, we need all these resources, all of those that are listed, to keep our cell phone lifestyle. Now, let this sink in for a minute. Which means, who is willing to give up a cell phone? Never touch it again. And let's do it with everybody on the planet. Yeah, right. Never going to happen. We are so dependent on those little devices. Our life, our social life. Without it, we sometimes feel like we don't exist. So, wanting it or not, you are tied to geology and mining by just carrying around a cell phone. I'm not even touching all the other products in your house, but let's stick with the cell phone for a while, right? So, looking at a cell phone again, everything in your phones is mined. There might be a small percentage that is grown, but most of it to this day is mined. Well, now comes a clincher. Our annual global cell phone production, by the way, if you're in economics, that is bound to increase over the next decade, is 1.3 billion phones a year. I want you to think about 1.3 billion phones. Okay, how much resources do we need to make 1.3 billion phones every year? Okay, so if you calculate this out just by the weight of the phone, 150 grams, 5.3 ounces, that means 195,000 metric tons of cell phones are produced every year. It's kind of staggering. How much is this in volume? 195,000 metric tons of cell phones. Well, in the volume, this is a little shy of 70,000 cubic meters or cubic yards. A cubic yard is very close to a cubic meter. This is pretty insane of how much cell phones we make. So let's take a look. Well, how much is a cubic meter or cubic yard? And see this in my little illustration here. That's about a cubic meter. So you've seen those shipping containers that sit around in harbors. The big ones are 40-footers. And so a 40-foot shipping container, this is the long ones you see in semi-trucks sometimes, they hold about 66 cubic meters or 66 cubic yards if you're with the American system. Well, okay, But we need a little shy of 70,000 cubic meters. How much is that? Well, if you look at a container ship that carries these containers, so 70,000 cubic meters comes up to a little bit above 1,000 containers annually. Now, that may not sound big. I mean, it's basically one of those ships full. Those ships can usually hold a little more. But really a ship full of those crammed full, bottom to ceiling, front to back, side to side, with cell phones. I haven't even included the packaging, which takes up some volume. That's just raw cell phones. So there's a lot of cell phones. And this is not just once and they're all gone. This is every year. And remember what I said? We always want the newest one. So one of those ships is coming over with your phone in it that is produced somewhere. Also a pretty insane number. So what that means is that when we have these raw materials, we need a lot of these raw materials that go into our lifestyle and preserving our lifestyle. Now, what you need to remember, this is just the bottom line concentrated, already developed material that goes in a cell phone. But what about the resources? When you mine stuff, you never get 100% gold, 100% copper. You don't find it this way in the ground. You find it in certain concentrations, and then you need to concentrate it more. So the mining, the block of rock you need to break out of the ground is way greater than the resource you get from it, right? We call this an R to M ratio, or rock to metal ratio. We need to mine a certain amount of rock from this amount of rock that includes overburden. We need to remove a material that is useless, that usually ends up as a mine tailing. We then need to concentrate this one as a ore, or need to extract the ore from it. Then the ore is further concentrated, recovered, and eventually, after we're doing this for a while, we end up with the metal product, with the pure metal product that we now can put into our commodities. So it's called a rock to metal ratio. How much rock do we have to mine to get a certain amount of metal that we produce? And they've run some analysis. It's actually fairly new to come up with this, because that tells us a little bit how big a hole we need to make in the ground to get our resources. And so iron is one of the most productive ores in the world. So it's a 9-to-1 rock to metal ratio. So with other words, of 9 tons of rock mined, we get 1 ton of iron. That is one of the best ones. I'll show you some of the not so good ones that we also need as a resource. What about gold? Well, here's the insanity of gold, rock to metal ratio. The average rock to metal ratio for mining gold is 3 million parts of rock to 1 part of gold metal. With other words, you mine 3 million tons of rock to get 1 ton of gold. Or 3 million pounds of rock to get 1 pound of gold. Most of our other metals that we exploit and that go into your cell phone are somewhere in between those two extremes. So we need to make big holes in the ground to get the materials we need to make our cell phones. So the median is about 1,000 to 1. And that is a fairly new study from 2022 that shows us that, yeah, we're making big holes in the ground to get our resources. Now remember, for our annual use of cell phone, if we use the median of 1,000 to 1, what we would need to do is, for all the materials in our phone, we need to remove somewhere around, give or take, I mean, this is really, really a rough average, just to get some numbers in our heads around this one, of 195 million metric tons of material that needs to be moved to satisfy our demands for new cell phones. Or about 1 million shipping containers of material that we need to mine every year around the world, wherever those things are produced or the natural products are recovered from. So, what does it mean for you? Everything that you like, that you think you need to have, is somehow mined. And there is a rock to metal ratio to pay for our desire to have our lifestyle. So you are tied to geology with almost everything you touch. And most people don't realize this. And that also has impacts in politics. When we say, for example, we can be independent of any other country, dream on. There are many resources the United States doesn't have. We need to import to have a modern technological society. Platinum is one of them, for example. We can never, from our mining activities, satisfy our demand for platinum. We have a little district in Idaho that is probably one of the most prolific districts to get platinum from. But that does not by any means give us our supply of the materials we need. So just by knowing a little bit about geology, you know the whole world is connected. We can't be an island. To have the lifestyle we're accustomed to, and the ease, and even if you want to call it a patriotic freedom we enjoy, you need to look at other countries that supply some of the materials. And some we can't. Some we could, with a little bit, we could be self-sufficient, self-reliant, but others we can't because they are just not available in the United States. Right? So whatever you touch is thinking about it. What about ceramics like toilet seats? They come out of the ground. Very special material called ball clays that are part of ceramics that our hands touch. And they are not be found everywhere in the world, but just by the whiteware there, by bathroom toilets and sinks and so forth, the white ceramic material that you see. One of the greatest suppliers of that stuff, believe it or not, is Ukraine. They have one of the largest world resources on the raw material to make those. United States, about 8% of the world market, somewhere in Kentucky, that provides material to make those. So that's something we need to import, believe it or not. Cars, I don't even get started on cars, even as electric cars. You can think about what all goes in the car. Even the paint on the outside. What's paint made out of? It's not grown, I tell you this. A lot of paint is actually a petroleum product. People are going, what? No way. Yes. Everyday articles like glasses. And you see the glasses, the metal frames. I'm just throwing a few things out of here. Our fashion industry. Oh my goodness. The material that goes into making clothes. The plastics. Nylon, rayon, you've seen a few of those. That's chemistry, raw product, often oil or natural gas. We're trying to do synthetic fibers out of other oils and materials. Not there yet. I don't know if they ever could replace the huge amount of demand that we needed to cover that. But everything you have that's made out of plastic, your clothes that you wear, is part of it. Everyday articles, toothpaste, toothbrush, all tied to geology. Cosmetics. You got to be kidding. Yeah, cosmetics are a big part of petroleum industry products. The pigments, the coloring agents that go in there. So resources, we need resources out of the ground. And just the awareness of that can make you make better decisions as you go around and thinking, oh, what am I using? And I'm really tied to the earth, wanting to or not. So that brings us to environmental issues. We all have environmental passions, and it's great. We would love to make the earth a little better. But there's also some realistic side to it that we cannot avoid. And sometimes we forget. We're thinking about stuff just comes from somewhere and we get rid of it somehow. We don't. The stuff that we get from somewhere is in large part tied to the earth. So let me use an example that may stir some emotions in many of you. Fracking. Some of the, yes, we need it to supply energy demands and that we can have the energy and the resources we need. And others say, oh, this is the most toxic, money-grabbing thing ever happened. No, we should ban it wherever we go. So it doesn't matter, or the point I'm trying to make, it doesn't matter which side of the coin you are, either yes coin or no coin. You can have very strong opinions either way. It doesn't matter. But here is something you should ask yourself. If you successfully campaign against fracking, successfully campaign against it, have you actually eliminated fracking? You got rid of it, you won a victory. Now here is the problem with that. From my own background, I'm from Colorado. We had this fracking issue, especially in a community here we call Longmont, where it was on the ballot, and people had an initiative to not allow fracking, and initiative passed, and so fracking is not allowed within city limits or certain areas here, and so it feels like we won a victory against fracking. Yes, we're making the world better, but here's the deal. As long as we want or need the products that are derived from the material that's produced by fracking for our lifestyle. See, this is the point. Nobody wants to give up the lifestyle they're having. Or we could give it up a little, but not to the huge extent. Nobody wants to go from a beautiful house to a mud hut. We say, no way. I work too hard in my life. I deserve a little bit nice things. But here's this, we need the products derived from fracking. So what does it mean? By eliminating fracking somewhere, we have not eliminated it. We just move it to a different location where they don't care or can't care about fracking. In the extreme case, we move it to a third world country, and who cares about what if people in Africa get sick or something. I'm facetious here, as long as we can have our lifestyle. And that's the sad part of it. And we need to realize in all decisions that we're making that no matter how passionate you are, it all comes down to lifestyle and the resources that supply that lifestyle. So, is it reasonable then to change our lifestyles globally? You may think, well, we should. We should. Well, let's start. I'm always doing this when I teach classes in colleges. And I make a suggestion. I go around with a basket. Everybody throw your cell phones in, and you're never going to buy another cell phone in your life. And then students look at me like, are you nuts? Well, and this is exactly the point I'm trying to make. There's certain lifestyle we're not willing. We will never be willing to give up. Maybe a few very hardcore environmental enthusiasts might do it, but the big masses, never. You will be always in the minority. So, knowing that, not saying it's a bad thing necessarily, but knowing this maybe makes us much wiser in the decisions that we make, both politically, both in our personal life, what we purchase, and how we treat our planet and use our resources. So, understanding geology then helps us to make reasonable instead of emotional decisions about our planet. And I think this is a big point. Many of our decisions are often emotional. We have this feeling, oh my goodness, and the news media doesn't help necessarily because they live from emotions. Clickbait, right? If you can invoke an emotion, even anger, you're willing to, I want to know more. I want to get really fed up with that stuff. So it is important to keep a level head and make reasonable instead of emotional decisions about those things. And think about what can we productively and effectively do without reducing necessarily our lifestyle to nothing. Is there a way? Now, they're not easy solutions. This is why we need bright minds and bright heads to kind of put their heads together and say, how can we balance this whole equation? Now, how much geology do we really need? I'm talking about it, you may be thinking, He's a geologist, so he's probably talking about geology all the time. But they have done some studies. For example, every American born will need, how much do we need in our lifetime? How much resources do you consume for yourself and for the utilities you use? Even the roads you're traveling on. The things that are made for your public enjoyment. So here's a statistic, a little sobering. How much stuff does our lifestyle demand here in the US of A for everybody that is born or lives here? So in our lifetime, and I know I'm not going to ramble them all off, but we is consuming about 512 pounds of zinc, 12,000 pounds of clay, 31,000 pounds of salt, about 1,000 pounds of copper, 40,000 pounds of cement, 6.29 million cubic feet of natural gas. Just look at the slide and you're going, wow. And then multiply it by the amount of people we have. So with other words, each one of us in our lifetime uses about 3 million pounds of product, minerals, metals, fuels that come out of the ground and are tied to geology. Now, can we reduce this somehow? That would be nice. I'm seeing here something called 17,617 pounds of phosphate rock for fertilizers. Part of it goes into your food that you see here. Phosphate rock, that's a commodity that's not very plentiful. Most people don't know that either. We might get shortages of phosphate unless we find other sources. They try to use bird excrements to extract it or some other resources, but phosphate mines are far and few in between around the world, just to throw something out there. So, then why geology? What everyone should appreciate actually about geology is the following, right? First of all, that we are incredibly dependent on the geology. Not only on the applied products we are getting from it, but also on the science itself. From pipelines to imports to extraction, even exports, we need to understand the economics that go with geology, that makes actually our society tick. Our lifestyle and associated resources are tied to it. You can't get away from it. You want a cell phone? Yeah, you need to pay it in what I call environmental currency. You want an electric car? Pay it in environmental currency. You want a nice house? Pay it in environmental currency. There's always something to pay. Of course, we can make things better, and sometimes technology can help. Recycling can help. Probably some of you think, yeah, we could recycle a lot. That is true. Some things we can. Other things, we are far away from making it recyclable. It's sometimes way more expensive. That's one of the problems. And of course, in an industry where we need to make money, doing something that's more expensive and something that's less expensive is always a difficult sale. How can geology make the world better? Now there's some inventions that have come up. We tried. They are not there yet, 100%. But you may have heard about carbon capturing. Where we take carbon dioxide out of the atmosphere and then we actually pump it underground and have rock react with it. Well, a product of geology, helping with that and what chemical processes are going on. Iceland is doing fairly good with this methodology. There's still more research to be done, so we need bright young minds to be involved in those type of things. Water becomes an important issue. How can we preserve it? How can we drill for it? What about groundwater? What about landfills that help not contaminating? What about our energy? Other things that geology can do, yes, they do, to make things better. And sometimes it's just the innovation. We're coming up with new innovations to make things tick a little bit better. Saving lives, it's huge. You all have seen terrible catastrophes, fires, floods, hurricanes, storms, tornadoes that ravage the countrysides in the United States alone, for example. Well, that's a novel idea. Somebody just came up in Colorado. They found out, brick houses fare fairly well in fire. Well, duh, brick doesn't burn. And so they come up, clay soil. Clay is very abundant. Can we use clay? Geology again, a soil, to make houses that are way more fire resistant and do not get leveled or burned to the ground in a fire. So there's a new industry emerging and new innovations to be had. But just thinking about, shoreline, how can we build houses better, safer, making them more tornado proof? I don't know if we can make it 100% tornado proof, but there is construction and there's also some geologic things that can be done to mitigate these property damage and in the end saving lives. For example, there was one community in Florida that did that. They built their houses according to some engineering with super drainage pattern, and in a hurricane, these houses, they're not more expensive than other houses, had way less damage and hardly any flooding because of the drainage was developed nice. Also part of geology that we often don't see, the geologic engineering of the ground and ground drainage, often geotechnical engineering that goes into that. And of course, not to diss beautiful landscapes that geology has created that makes the wonders of national parks in our beautiful country actually something worthwhile visiting. So if you have never been to a national park, I would say get a pass, get out there and enjoy these summers. Beautiful, breathtaking landscapes you can see, all part of the geologic development of our planet. What about science? Where does geology fit in? Well, geology is a vital, as you've seen, is a very vital science, but it's underappreciated. Some people even don't know, what's geology? I've never heard about it. Geology is a science, really? I thought it was just something like geography, something we knew. No, it is a science, and it's an unusual science. But it is underappreciated. That shows in our public education. We teach rather chemistry, physics, biology, or computer science. And if we teach anything in geology, it's very, very little. Just a few cool stuff, minute topics. But this discipline is so huge, it has such a huge breadth and such a huge width that there's so much more to it. But we have, small things like dinosaurs, few crystals, volcanoes, and maybe the rock cycle. And it is often it. So much more to it. But here what you need to realize, geology is a STEM science. It belongs to the science, technology, engineering, and math disciplines. In fact, all the big sciences are actually combined into geology, including some other natural science disciplines. So if you want to have chemistry, geology has it. You want a physics? Geology has it. You want some biology? Oh my goodness, geology has it. Yes. Well, the thing about dinosaurs. What about computer science? Oh, the advances in geology and computer science are enormous. What about other science like meteorology? Yes, geology has it. So geology is one of those sciences that includes many, many, many disciplines. They're all in there. So what is unique about geology? Rather than focusing on an area or another of science, like chemistry or physics, geology uses all the principles from all these sciences. It's really an interactive and interdisciplinary, integrated system that is there to have new innovations and solve problems in an applied sense. So this is why we all should know a little bit about geology, what it does, how it works, how it impacts our economy, how it impacts our decisions, what can be done, what we need to work on, and what are actually some of the things that impact my life that are related to that science. So, what about geology? Well, it's much more than you think.